Okay, so we are now going to talk about how to analyze our data. So if we look here, we have a problem that's very similar to what you guys did on Friday with the running. So we have a boy who is riding his bike. He started at the start line time of 0 seconds. So that makes sense. So he's starting at a start line for 0 seconds. So if I have a picture, I have a start line, and his time is 0 seconds. So now the boy is going to ride his bike 10 meters in 10 seconds. So I have a distance and a time measurement. Then he stopped for 10 seconds. So just like you, at the midpoint, you stopped and counted for your pause. That's what this boy is doing. So now he is riding his bike 10 meters in 10 seconds. He gets to this point, which is 10 meters away, and he takes a pause for 10 seconds. All right, so we could graph this now. So let's look at our chart. His start time was 0 seconds. His time to the 10-meter mark, which is right here, was 10 seconds. And his pause now was 10 seconds. So now let's look at this. Let's graph this. So the first part should seem like a review. He's starting at 0 seconds, he's going for 10 seconds, and he's going a distance of 10 meters. If we look at our distance graph down here, we have time in seconds, we have distance in meters, and I went ahead and labeled the start line. 10 meters away is the midline, 10 meters away is the finish line. So what did our rider do? He started at 0 centimeters and went, or 0 meters and went to 10 meters. So in a time of 10 seconds. So it took him 10 seconds to go up to 10 meters. So put a dot, and we would connect this line to the origin. Now we've been doing that. So this is what we've been working on. Now we have a second part. He takes a 10-second pause. So our time is on the x-axis. Our distance is on the y. Now while he took his pause, he didn't move anywhere. So he stayed at 10 meters for a time of 10 seconds. So if we're at 10 seconds, where he got there, he's taking a pause for 10 seconds. So we're going to extend our 10-meter line for 10 seconds. So between 10 seconds and 20 seconds, he took a pause. So this flat line means he is not moving. He is standing still. So now he started, he rode his bike 10 meters in 10 seconds, stayed at the 10-meter mark, and took a pause for 10 seconds. Now let's see what happens. So we did this step. Now we're here. Then he rode his bike back to the start in 20 seconds this time. So if I have my picture, he took his pause, and now he's going to go back to the start line, which again is still a distance of 10 meters, still 10 meters right here. But this time it's taking him 20 seconds to do it. So time back to start, it took him 20 seconds to get there, and the distance to get back to the start line is still 10 meters. So if we look at our distance graph, he needs to go back to his start line. It's going to take him 20 seconds to do it. So if he's at the 20-second mark right now, it's going to end up 40 because 20 plus 20 is 40 seconds. It takes him 20 seconds. So he's going to end up back here. Now, we got to think, is he going towards the finish line, which would be this way, or is he going back to the start line? The problem says he rode back to the start in 20 seconds. So that's back this way on your graph. So he is at, right now, the 20-second mark and at 10 meters. He needs to end up back to the start line in 20 seconds. So we'll put a dot here, which means we can connect our lines. And this is what our finished graph looks like. He started at the 0 time and 0 meters. He rode his bike for 10 seconds, 10 meters. He then took a 10-second pause, signaled by this straight line. He then went back towards the start line, and it took him 20 seconds. So if he leaves his pause at 20 seconds, Takes him 20 seconds to get there. He's going to end up back at the start line at 40. Put a dot, and we connect our line. So he goes away from the start line, takes a break, comes back to the start line. Now, let's look at the distance. How far did he go total? So he rode his bike 10 meters. Then he took a pause. He's not going anywhere here, so that's 0 meters. Then he is returning back to the start line 10 meters away. So he went a total of 20 meters. Now the displacement is how far he went from the start line. So he is starting at the start line and he is ending on this same line. So his displacement would be 0. He went 0 meters away from the start line. If you closed your eyes when he said start and then opened them 40 seconds later, he would be in exactly the same spot. So his total displacement is 0.